This is May 2012, paper 2 time zone 1, and it is question 9, a question all about binomial expansion. Find the constant term in the expansion of x minus 2 over x to the 4 times x squared plus 2 over x cubed. So the constant term means the term that does not involve any x's. It's just a number. Because it doesn't involve x, it doesn't change with regards to what x changes to, hence the name constant, doesn't change. And it turns out you can save yourself a lot of time by not expanding the whole of this expression out. But it's worth thinking about what the whole thing would expand to, because it's not obvious that there's only going to be a small contribution for the constant terms, I don't think. So let's split it into two sections. So this section, x minus 2 over x to the 4. If you expand that out, our binomial coefficients are going to be 1, because it's the 4, 1, 1, 4, 6, 4, 1. It's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. This is paper 2, so you can use your calculator to evaluate those if you haven't got them memorized. So what does that mean? Well, that means the first term of our expansion is going to be 1 x to the 4, and the last term of our expansion is going to be 1 log of minus 2 over x to the 4. Hopefully I'm going to have enough space to squeeze the other three terms in between, so let's take them in turn. The first one, x to the 4, the next one's going to be 4 lots, because that's our binomial coefficient, of x cubed multiplied by negative 2 over x. And already I'm starting to think I'm not going to fit it in. Next bit is going to be 6 x squared times minus 2 over x, also squared. Next one is going to be 4 x times minus 2 over x cubed. And the last one is going to be minus 2 over x to the 4. I already said that. Just erased it because I ran out of space. Now, before I do the other bracket, which is done in exactly the same way, I just want to point out sort of how you can be a little bit, maybe, more efficient if you think about what's going to happen before you get started. So, if we take each of these in turn, it should be obvious that the 4x, the x to the 4, that's not, well, maybe it's not obvious, but that's going to be x to the 4 once it's evaluated, right? This one, which I'll highlight in yellow, once it's evaluated, x cubed divided by x is going to be an x squared. The next one, that's going to be this one that turns out to be key. That's got an x squared and a 1 over x squared. That's going to multiply to make a constant term, no x's. X to the 0, effectively. So I'm not looking at the numbers at the moment, I'm just looking at the powers of x that are going to be in each one. The next one, well, that's going to have an x divided by an x cubed. Maybe I should write this out. X over x cubed. So that's going to be 1 over x squared, or something over x squared. And then the last one is going to involve an x to the 4 in the denominator. So here I just end up with something over x to the 4. Come on, for completion I'm going to stick the x to the 4 in at the start. Okay, I'm going to come back to those in a second. Let's just quickly evaluate this expansion by doing something similar. So this time the binomial coefficients, and these you really should have memorized, are 1, 3, 3, 1. Watch out, we've got the x squared here, so the first term's not going to be x cubed, but it's going to be x squared cubed. Next one is going to be x 3 lots, because that's our binomial coefficient, of x squared squared times 2 over x to the 1. Our next one is going to be 3 lots of x squared to the 1 times 2 over x squared, and the last one is just 1 lot of 2 over x cubed. Again, because I want to be a bit clever and a bit efficient, I'm going to see if I can, what I can do with these terms. So the first one will be x to the 6. The next one, I'm going to use a similar colour scheme. Well, that'll be x squared over an x. Again, I'm ignoring the numbers for the second. I'm just looking at the powers of x. The next one will be an x squared over x squared. So that's our constant term again. And the last one will be something over x cubed. So there's a lot of things I'm doing here that you might do in your head when you're actually writing it down. But the question is, where are we going to get any constant terms from? Now, there's one obvious one, and it turns out that it's going to be the only one, but you've got to make sure you think about it. So the obvious one is when we multiply the constant term on the left with the constant term on the right, then there won't be any x's. The question that you should be asking yourself is, are there any other points where we could get a constant term appear? Well, in order for this one to give me a constant term, when I multiplied it, there'd have to be an x to the minus 4 over the other side. X to the 4, x to the minus 4, if I multiply them together, they would multiply to make x to the 0, so a constant term. And you can see there's no, if you look at what's available on the other side, there's no x to the minus 4, there's no 1 over x cubed on the right hand side, so there's no way that when I multiply this x to the 4, it's going to cancel out and leave a constant term. And you can go through the same logic for all the others. There's no x to the minus 2 in the right hand bracket, so I could ignore that. There's no 1 over x squared, so there's no x squared in the right hand bracket, and there's no x to the 4 in the right hand bracket, and by the same logic there's no partners for the things on the right hand side in the brackets on the left either. So all that really remains is for us to take the peach term from the left and the grey term from the right, evaluate them and multiply them together. So the peach term 6x squared times minus 2 over x squared, and the grey term is 3x squared times 2 over x squared. So just that gives me 6x squared times 4 over x squared, like that. And the grey one is 3x squared times 4 over x. Oops, squared, missed the squared off. That's the whole point. The x squareds cancel. The x squared there cancels with that one. The x squared there cancels with that one, and I'm left with 6 times 4 times 3 times 4. This is a calculator question, so it's just a case of evaluating that. It's very noisy because it's suddenly lesson change over time. 24 times 12, which is 288. And that's our coefficient of the constant term. Well, that's our constant term.